So graphing using intercepts is going to help us when we're in standard form. So here we're going to take like 4x plus, let's say 6y equals 12. It helps when your a and b terms are factors of c. So kind of thinks a little bit of factoring-esque, but not terrible. So graphing with your intercepts help out. You want to ask yourself, does 4 go into 12? Yes. Does 6 go into 12?
Yes.
Yes. So then you want to, graphing by intercepts can be a lot faster. Sophia, do you agree with me? They can be a lot faster. Now, if I had, say I had an equation like 4x plus 7y equals 12, graphing with my intercepts is just going to make it more challenging because you're not going to have like an exact point. It'll be like a third or it'll be a fraction. It's a little harder to move. So up here, we're going to try with our x-intercepts first. So the x-intercept is the point where the graph crosses the x-axis. Can you read that or not really? Here, I'll change to a different color. All right. The x-axis, the x-intercept happens when the y-coordinate is, no, not the y-coordinate. What am I talking about? The x-coordinate is, no, not x. No, y. I'm right. Yeah. Ugh.
I'm so confused.
The y-coordinate is 0. I'm overthinking it. Okay? To find the x-intercept from an equation, we're going to replace y, or f of x, with 0 and solve for x. Sorry. So we're going to substitute for the other one. Okay? So here we are with 4x plus 6y equals 12. I want to know what my x-intercept is. So I'm going to go in and I'm going to substitute 0 in for y. So when I solve that, I would get 4x equals 12. So x is going to equal 3. So I know my ordered pair would be 3, 0. Because I plugged in 0 into there. Our next setup, so does that make sense? Sorry, I messed up that one. All right, the y-intercept is the point where it crosses the y-axis, and it happens when the x-axis, or x-coordinate, sorry, is 0. And to find the y-intercept from an equation, we're going to replace x with 0 and solve for y. So I'm going to do 4 times 0 plus 6y equals 12. So 6y equals 12, and y would equal, so now I know my point would be 2, 0. Oh, no, 0, 2. And then we can just go and graph this. And we're going to draw a real quick graph. I'm going to go 3 in each direction. So I go and plot a point at 3, 0 and 0, 2, and then use that ruler and draw the straightest line I can. Most of this up here you can kind of do mentally in your head. You don't necessarily need to write all that work out. Okay? And that's our intercepts. So if we look at our graph, the one I just passed out to you, so sometimes I like to do it also, that kind of makes and saves myself some time and energy, is just kind of cover up the other variable. So what's my x-intercept going to be if I plug in 0 for y? X would have to equal 2. So I know I'm going to have a point at 2, 0. And what's my other one going to have to be? At 0, 2. And then I just go and plot those. And remember, you only need 2 lines to make a 2 points to make a line. And then, oops, and you're going to do it way straighter than Miss Matchgree. So over here, let's find our x-intercept. So does 5 and 3, do they both go into 15? Yep. So 5 times what? If I plug in 0, that would have gone away. 5 times what gives me 15? 3. So I know my x-intercept is going to be 3, 0. And then I'm going to cover up over here. Negative 3 times what gives me 15? Negative 5. And then I'm just going to go plot those points. And then get my lines going over there. Okay. X and Y intercepts makes a little easier if you get it into standard form first. So how would I get this into standard form? What do I want to do with this 3x? Subtract it. So really I'm going to have negative 3x plus 4y equals 12. You can do it the other way around. It doesn't really matter. So does negative 3 and 4 both go into 12? Yep. So when I cover this up, negative 3 times what gives me 12? Negative 4. So I know I have negative 4, 0. And then I'm going to cover up over here. 4 times what gives me 12? 3. Do you see how this is a lot faster than graphing? So it kind of wants to be your first step and be like, do I have A and B, are they factors of C? Kind of like when we were factoring, we always asked, was there a GCF first? Because it made it the numbers a little easier. Okay? All right, and then last one, we're in standard form. So 2 and 1 go into negative 8, so we're good there. So 2 times what gives me negative 8? Negative 4. And then that just has to be negative 8 because it told us. I'm going to go to negative 4 and then to negative 8.